Hello, Professor. My name is Walid, and today I will be speaking about my research paper, which is named Optical Access Network for Smart and Sustainable Cities. In this presentation, I will be explaining the paper from my own understanding in a very simple way. I will talk about why the smart cities need a strong network and how optical access network and the PON network can help. What the technologies the author proposed, and finally, I will share my opinion and the strength and the limitation of the paper. Firstly, I will explain the problem, why the current networks are not enough for the smart cities. Then I will talk about the main idea of the paper. After that, I will explain the two PON architectures and the AI-based monitoring. The also the mobility allocation, resource allocation, and the fiber deployment study. At the end, I will be discussing the real demonstration and my evaluation and the future work that the authors proposed and the future work that also I have proposed. The smart city have a very big challenge of the network. In the future, the cities will have millions or even billions of connected devices like sensors and cars, cameras and smart buildings. They will be all connected in the network. All these devices will need in the future a very high data rates and very low latency and a very high reliability as well. Wireless technology like 5G and in the future and the 6G are very important, but they cannot work alone. They all must work together. Like each city cannot have just a 6G network or just like in the future to be 5G, because 5G will be very slow in the future. So they all need to work together in order to provide a very high speed internet connection to the citizens. They always need a strong fiber network underneath to carry all the data. The main idea of the research paper is really simple. If we wanted a smart and sustainable cities, we must focus on optical access network, or as it's called, PON. Not only core networks. The author also says that the PONs, or passive optical networks, are the best solution because they are scalable, cost effective, and also use point to multiple points connections. The people tries to study this problem in a complete way, not only one part. This paper is very broad. It doesn't focus only on one thing. It studies future high-speed PON architectures, AI-based monitoring using machine learning, and smart resource allocation that considers mobility and fiber deployment planning. Also, a real smart city demonstration. So the paper is more system level, not only theoretical, because they have applied all the knowledge that was in this research paper in a German city, which we speak about later on. The first architecture is 100 gigabit per second uh, passive optical network, or PON, using IM and DD, which means intensity modulation and direct detection. And this approach is simpler than coherent systems and cheaper and easier to deploy in access networks. The goal here is to check if 100 gigabit PONs can realistically support the smart city's needs with a normal city distance. The results shows that the 100 gigabit IM and DD PON network works well, but and this system achieves a link budget about 30 dB, which is enough typical urban fiber distance. This means that the 100 gigabit PON is feasible and can support many smart cities devices without extreme complexity. The second architecture is more advanced. It is a 200 gigabit per second coherent PON, which stands for passive optical network. Coherent systems are more complex, but more flexible and more scalable. The author used digital subcarrier multiplexing, which allows the system to grow step by step and coexist with older PON generations. The result of coherent PON are very strong. The system works over 20 km fiber, supports very high losses, and can coexist with legacy PONs, like the previous PONs. And this shows that the coherent PONs are very strong candidate for future smart cities where very high capacity is needed. One important problem is in fiber networks is monitoring and fault detection. Normally, engineers analyzes the OTDR traces manually, which is very slow and not scalable. What is OTDR? OTDR is optical time domain reflectometer. reflectometer. This is OTDR means. And the author uses machine learning, especially a random forest model, to automatically classify the OTDR events. The AI model achieves much higher accuracy than the traditional methods, which shows that the AI can really help the network operations. In smart cities, many users are moving, especially the vehicles. The traditional bandwidth allocation doesn't consider mobility. The authors propose to predict the movement of the vehicles and allocate the bandwidth before the handover happens. This helps reduce the latency for the time-critical service like autonomous driving. The latency metrics. The result shows that the critical services latency can be reduced to around 1 millisecond. 1 millisecond is too less, but I think when we have something like the electric cars, especially in the future, the electric cars will be like fully working with via Wi-Fi connections. It will be connected to the network, and everything will be taken from the network. So this 1 millisecond will be very dangerous for the autonomous driving cars, because the cars are driving really fast and each millisecond matter. So if a car came in front of that car, it might crash in this 1 millisecond if it didn't move, if they were late 1 millisecond. So that's why the latency is really important in the optical while we are developing the optical access network. But there is also a trade-off. When a prediction is not perfect, non-critical traffic can experience higher latency. Yeah. So when there is traffic, because the autonomous cars are consuming a huge putting a huge pressure on the network. So yeah, so the idea is good, but its success depends strongly on how accurate the mobility prediction is. The paper also studies the fiber deployment cost. So as we said earlier, we can speak about the city that this paper was like they implemented the paper on that city, and they studied that city. The city is in German called Karlsruhe. This is the city, and the population of this city is around 300,000 people. So it's not a large city. It was a small city. That's why the 100 gigabit per second PON network and the 200 in the future, it was working, because the city is very small and you can deploy the high-speed internet in it. The main result in that city, in this study, was like the most expensive thing while developing this deployment. The most expensive thing was trenching. Why? That's why they wanted to focus on planning, and they said the planning before trenching or even before starting to implement anything in the network is really important, because trenching can destroy the city's infrastructure. So the technology is not only the most expensive things, but trenching is the most expensive thing. And deployment results. One very interesting result is about the future proving. While they were deploying in that city, they added like empty ducts. For example, if they wanted to deploy one fiber optic fiber, like one fiber, they were adding two empty ducts, because the most expensive thing is not the ducts but the digging. And when they added two empty ducts, the cost was only increased by 2 to 3%. So they will be saving a lot of money in the future. If you were asking why they're not adding like filling all the tree with the fiber optic network, like to make the network stronger, they're leaving it empty for now because they doesn't know what will happen in the future, what will be the new technology that will exist in the future. So they're just leaving an empty ducts, so in the future the new technology can be added later on. The authors also showed a real smart city demo where the PON network supports a remote assistant from an autonomous vehicle. So they controlled an autonomous vehicle from the network remotely. From my point of view, this paper is very strong because it connects the technology with AI, with the economics, and they have a real deployment as well. So, but the main weakness of this paper, it's very broad. Like the scale of the research paper is very wide. From my point of view, I think it would be better if they focused only on one thing and really like solved the problem and deployed it. This is my point of view. For the future, I think they need a better AI prediction. Also, larger AI city scale experiments, because the experiment that they did, it was on a really small city, and comparison with other access technologies would make the work even stronger. Also, I will add one more thing. This is from my personal experience. I'm also working, like my graduation project is AI agents, so I understand the AI prediction. The AI prediction that they have, it's good, but they need to improve it, and they shouldn't depend on the AI agents, because the AI cannot be true all the time. And when the thing is about the city, like you can analyze the data of the city via AI, but you cannot depend on AI in this project. I recommend the authors to use automation instead of AI, because AI is only predicting and it's not true all the time. But if you had automations, the automations works. If this is right, then this will happen. If this happens, then this will happen. This is the automation. The automation is much like you can achieve 100% uh, rightness or truthness via automation instead of AI prediction. This was everything from my side. Thank you very much, Professor, for listening, and I hope that I could explain this research paper in a really simple way, and I hope that I could deliver the summary in a good way. Thank you very much, Professor.